Hey everybody, welcome to Houdini Hangout. It is the 30th of November. It's the last day of November today, which feels a little crazy. Feels like the year's flown by. We're getting into December here, but um, hopefully everybody's doing well out there. Looking forward to this evening. I think it'll be pretty interesting to maybe have a little bit more of a conversation than, per se a training session. So I'd encourage people to go onto the Discord server and just post some stuff in there, and see what just kind of see what kind of questions people might have. Got a few replies there. So thank you for doing that. But also, if you're watching tonight, feel free to drop some questions in the chat, and we'll kind of get to them as we go along. As I was going through and like collating some of these questions before the stream tonight or whatever, putting them onto a document, I was like, I probably should have figured out a way, and not that it's that complicated or difficult, but just made a way for me to be able to show the question on screen. So my apologies for not being as broadcast savvy as I should be. I know how to do that. It's just maybe the best way to do that for this type of situation. My world is a little bit more on like TV broadcast than like YouTube broadcast. So sometimes it takes a little bit for me to get my brain around that. But anyways, that's kind of the idea for tonight. We'll see how this goes. I never really tried this before, but it was something that one of the guys, actually in the marketing team of Side Effects, when we were in Austin and New York for our Hive events. We were chatting a little bit about the stream, and he was like, "Oh, you should do like a Q&A session. You ever done that?" I was like, "Oh, that's kind of." I mean, I've done stuff before where people have brought up questions to me live on air, and as far as like, hey, how do I do this? But this is maybe a little bit less going to be how do I put down X node in Houdini, and more about like conceptually maybe some higher level thoughts and ideas and things like that. So hopefully this will be something interesting to you guys. But either way, it should be pretty cool. And another thing I just wanted to mention was that if you go on the Discord server or on the YouTube channel, I put an update for the there was like, we were doing some grass and ground type stuff, like where it was like the ground was like a piece of fabric almost and the grass was attached to it. I put an update out for that. So if you had watched that previously and were like, oh, this didn't really go anywhere, which it didn't at all in the actual live stream I did. It kind of felt like it fell flat a little bit. We ran into some issues, and I think I just had some major brain farts, and updated a couple things and made kind of a whole new stream of that. Basically, it's pretty long, but you could definitely kind of go through it, find the different concepts that we start working with there. It's very similar, and in the end, I kind of just end up fiddling with some stuff and get some kind of dial some stuff in, but the kind of bulk of it is at the front end. So hopefully that'll be helpful if you had seen that or watched that stream a couple weeks ago and you were like, oh, I wasn't really happy with how that came out, or you felt like it kind of was I don't know, whatever. I felt like it wasn't great, so I wanted to make sure I made a better attempt at the same thing. But anyways, so let's start to maybe get into some of these questions. And like I said, if you have anything that you want to put in the chat here live while we're talking, please do that. Even if you're after the fact and you're watching this video on YouTube, probably, feel free to put it in the comments below. I try to keep a okay eye on comments. It's a little weird. I, for some reason, don't get the notifications always on my phone. So I try to keep an eye on it from time to time. But so hopefully if you do have a question or something that maybe falls in this kind of category that we'll be talking about tonight, you could always drop it in the comments below. But anyways, so I'm going to go through a few different questions here. I've got maybe like half dozen to like probably about 5 to 10 questions maybe. that are kind of like overarching ideas, and I'll try to talk about them a little bit. And I really love, even if you're watching now live and you have some comments on these things or just questions, feel free to drop those in chat as well. Just as with any of the stuff that I do on this channel here, I really, would like this to be more of a conversation, less of me just talking, at you, but you being able to kind of chat back and figure out, maybe come to some other interesting ideas and things like that. So please, comments are welcome here. So so the first question I'm going to try to talk a little bit about is this: what were your biggest personal roadblocks to understanding Houdini, and how did I overcome them? And if you have an answer to this question, you can feel free to drop it in the chat or drop it in the comments below, whatever might be appropriate for you watching now. But for me, just a little bit of history about myself. I came from working my design / creative kind of background comes from kind of an outlet of being a musician. So I was a musician, then I got interested in working with stuff for our band, like website stuff and maybe design for t-shirts or whatever. I started getting interested in those types of things. And from there, I started doing, getting into graphic design and photography, worked at a photo studio for a little bit as an assistant, which was amazing for, working in 3D and stuff like that later. And working with video. I've done plenty of video production in my days, but from there I started getting more into video production, animation, things like that. And once I started getting into video production, I realized, man, I really love After Effects. I really like how this all works, and started doing that a lot. Went to school at that point. I'd worked kind of just a little bit in the industry, but real entry level stuff. And then went and got a degree, learned about like cinema and 3D and stuff like that, and started to, hey, what's up, man? Peter, nice to have you here. So it's so interesting to have another Peter person around. I'm not used to having other people named Peter, so it's very funny. I know very few other Peters in my life, so it's nice to have you here, Pete. Anyways, or Peter, whatever you would prefer. I actually am perfectly happy with Peter, but most people call me Pete. Anyways, we'll have to battle. Yeah. See who comes out on top. All right, I can't say that I would be very good in a battle. In fact, I was in a Houdini battle even at SIGGRAPH and came out in 4th place. So, not sure what battle I would do very well in, but yeah, that's fun. Anyways, so I was doing 3D. I started doing 3D stuff in cinema, started getting into that, doing modeling and things like that. And I always gravitated towards, more effects and things like that. Like I really liked this, doing anything with smoke in there. I used doing thinking particles in Cinema 4D, which is like bashing your head against a rock, but that was what I started using. And, just doing all sorts of things like that in there started getting me interested in effects. So once I started at D Post in Buffalo, which is a small studio, but we were doing some fun. They were doing some pretty cool stuff. And once I started working there, we started wanting to do more fluids and, cloth and smoke and explosions and all, debris and all different kinds of stuff. And we were like, man, there's got to be a better solution. And it was SIGGRAPH in 2015 when I first heard about Houdini. And the first thing I realized when I was starting to do this was, darn, I wish I could go back to school for this stuff, because it felt like what I needed was computer science. That was what I felt like I needed most getting into Houdini, because really at its core, Houdini is programming. It's very visual programming, but conceptually you're doing programming on some level, whether it's in SOPs, whether it's in VOPs, or of course in VEX, you're going to be doing coding, right? So for me, that was one of the biggest things that I was like, oh shoot, like there's so many, computer science concepts in here that I didn't really understand. And for me, it was the guys at at Intagma, actually before they even started Intagma, I think it was Manuel was doing some, or Manuel or whatever his first name is. I always am bad with foreign names. My apologies. But he was doing stuff with cinema and doing like really advanced cinema stuff. And he then got into Houdini from there. I'm not sure what Moritz was doing, but because I only found out about him after watching Intagma. But those guys kind of started getting, it was from that I started realizing like, okay, here's how this kind of computer programming stuff works with for loops and, while and if statements and all these different things. And really, I think just understanding those few basic concepts really started to get my brain going, because you can do a for loop in SOPs, right? You don't have to code that. You can have a for loop right there that you're looping over geometry and stuff. That's a super powerful and very common workflow. Hey, Crossfader, how you doing, man? Yeah, back to maths. Yeah, and there's another if you guys check out, hey, how's it going? If you check out his Twitter account, he was actually posting some stuff recently this week about Houdini School. And I know Deb, who runs that, she was with us at the Hive events as well. Great resource for I think Crossfader was doing some math concepts for Houdini and things like that, or just for CG in general. And that's kind of the other thing that I was just actually about to talk about. And okay, there you go. Math for Artists is the name of it, and I think that's David Torno that did that, and he does some really great training on their platform as well. So huge shout out to them, and I can't recommend that stuff enough. But so for me, the computer science stuff was one real missing piece for me. And so then the other issue was maths, kind of like what Crossfader just said. Like, maths was a huge part of it, and specifically linear algebra. Like, that was a thing that was very confusing to me. I didn't really understand it. Now, I'm my background education wise, I always loved math. So I'm kind of a little bit of a weirdo in the CG kind of design world, where I liked math and I liked that kind of stuff. I loved doing expressions in After Effects. I loved that coding. So I always kind of liked the more mathematical, technical stuff. But Houdini School didn't exist, probably 7 years ago when I was learning this, and Houdini was pretty new. Not new, sorry. Houdini wasn't new, but Houdini for MoGraph was definitely a very new concept. Like, it wasn't a thing really that was happening as much then, or just had kind of started becoming big. And so I was like, well, I'm just going to do like Khan Academy linear algebra, right? Which you then have, like, as opposed to doing something like Maths for Artists, where you're literally putting these things together in real time and like understanding how these things go together, I was kind of discovering what linear algebra was, just on like 2D, references, and then kind of moving that into 3 dimensions. So the maths was a little easier for me, but I think that those kind of two things are the real, like, if you want to have a solid understanding of how Houdini works, understanding what, just vector math, some of the basics there, what you're doing when you're adding together vectors, dot products, cross products. I mean, matrix math is kind of the deep end of all of that, but understanding a little bit of how matrices work is good. But yeah, super recommend the Houdini School stuff. Check out that stuff. That would be probably a huge benefit if you're kind of struggling with some of the more mathy concepts of Houdini. Why is this calculation happening this way? Why is this happening this way and stuff? So like, I generally tend to really like math, so it isn't as huge of a stumbling block for me, and I can just kind of pick it up. But that is usually a big thing for people. So, just that's, those kind of two things are my personal roadblocks that I had an issue with. Like, all the 3D stuff kind of made sense to me, and all that kind of stuff, because I'd worked in 3D already, so that wasn't really that complicated. But I think those two things are kind of that's what I found, but I feel like a lot of people run into that same issue. So just that's kind of my 2 cents on it, and I'd love to hear, if you guys have any other thoughts on that. But those I think are roadblocks that most people that are doing Houdini run into, and certainly as someone who's now dealing with educational stuff on a daily basis, not just for the stream, but obviously in my job is as a training lead and helping educators and stuff like that. So, that's those are things that come up a lot, and we hear some of these kind of roadblocks. I think the other roadblock is just that Houdini seems really scary because there's so many. You're like, oh, do I have to memorize every node? Do I have to memorize every, whatever there might be? The answer is usually no. You don't have to memorize every node. That would be kind of insane. But it certainly is helpful to have at least an understanding of the basics of nodes, and then you kind of learn from there. But I think really math and computer science are the biggest roadblocks that I've run into. So anyway, hopefully that's kind of a interesting, kind of topic, and that's kind of my own personal thing, and you'll probably run into other stuff. But okay, so that's was one of the questions, and like I said, please drop questions in the chat if you're interested in having a conversation about something. I've got a few kind of outlined here that I want to talk about. We might open up some Houdini and play around with some stuff maybe in a little bit, but I'm going to kind of walk through some of these more high level things and then kind of go from there. But yeah, any questions, please drop them in chat, or if you're watching later, you can always make a comment, and we'll try to at least have some sort of conversation, or you can join the Discord server. If you go to HoudiniHangout.com, you can log in on the Discord server, and there's plenty of different places there to have conversations about how to do things, make suggestions for a stream, for topics and things like that. So anyways, all right. So another question was, what do you feel are the most underutilized or least appreciated aspects of Houdini? And it says in parenthetically, from the eyes of side effects, which I can't say I can speak specifically from the company as a whole, but underutilized, least appreciated aspects of Houdini. So I think I'm going to say one thing, even though I don't think it's not appreciated or underutilized, but I think people are a little wary of it, is I think Solaris is a little scary to some people because of some of the USD pitfalls that you might run into. And it is very non-Houdini in some ways, like there's some things that really have to change on a fundamental level for you to be able to, the way you work, to be able to use USD. So I think some of that makes people scared and think, well, Solaris is this, and I don't want to use it because of this, or, make a list. And there's certainly some still things that need to happen just within USD period, that are issues that need to get addressed and are in the process of getting addressed. And I think I've talked about that a little bit in the past, but I think that's one thing that I think a lot of people don't appreciate, the actual power that's there. Like when you start getting into lighting and look dev and all that kind of stuff, like the lighting tools in Solaris alone are fantastic. Like just being able to, like, the way you can move your lights around, and if you start learning the hotkeys and stuff like that, like I'm not in there every day, so like it takes me a second to relearn the hotkeys, but once I'm like doing stuff in there with being able to point lights and put specular highlights right where I want them on objects, is like, oh, it's so nice, and everything's right in the viewport, and like that is really nice. So I think that's one thing that's not appreciated fully yet. It is still kind of new. I mean, it's not new. It's first was released in 18. But I think a lot of people are still a little maybe scared of that. So that's one thing. And it's just something I've had a lot of conversations about that in the recent months and the past year. So that's very fresh in my mind. I think another really underutilized, especially for individual artists and, for people, maybe small studios, another thing that's really not well used is tops, using PDG. And I think a lot of people again get a little freaked out by how different it is as far as like a workflow. Um, but pretty much whenever I want to like batch process anything in Houdini, I'm going into Tops and doing something in there because it's just it's so well, especially at this point, it's so well integrated in so many different things in Houdini that it makes things so easy. So like a for example for me, I'm in the process of doing some stuff, some coursework for teaching instructors and things like that. And in that, I wanted to make a bunch of assets, right? And I wanted to be able to, I basically had this huge shelf of decorations, right? And what I wanted to do was take those decorations, like they were like picture frames and like vases and like books and all these different things. I wanted to turn them into individual USD file, like, assets, then turn those into like, stacks of books or books between bookends or, different things like that, so that they're kind of varied, and make this whole like process of like, here's how you take one USD asset and turn it into multiple. And then here's how you take that and make variations on that. And then here's how you take those and maybe scatter those into other objects using Solaris and make shelves and things like that. And so the problem was starting with a packet of assets usually isn't the most cleaned up process. Like even just like, hey, they're not all at the origin, or they're not all lined up the same way at the origin, or they're scaled slightly different, or whatever, X number of issues. In this case, it was just that the file that I got was a bunch of assets already placed on a shelf. And I was like, okay, I need to get these all to the origin, right? I need to get these all, saved out and done, working in some specific way, and then process through those as USD files. Well, once I had them all, set to the origin and maybe with naming or with grouping, I can't exactly remember what I did at this point, but I think I actually named that, made sure they all had names and things like that. Like they were fairly clean coming in, but they weren't perfect. And so I think what I did then was brought those into Tops. You can actually bring in things from your geometry into Tops and make work items for each, for example, named object in there. So each object gets its own work item in there. And then from there, you can start doing things like, okay, I want to process each of these files into USD assets and load them and save them. You can kind of string together Tops nodes that will run different render operators, different ROPs, and kind of do those in succession. Make sure that, when you're running this one specific one, it's loading in this file up here and saving it down here and maybe changing some stuff in the middle. I think, and really, I think it was like 30 some objects and just did a top network, did a couple things with it. And I have had to rerun this several times. And it's just so nice to be able to just hit the top network, have it rerun all of these USD assets, pump them out, and I've got them all set there and they're all basically written to disk. And having something like that isn't done through Tops, to be able to iterate through that would be slightly challenging. I mean, there's obviously ways to do it, but it's just such a clean way of iterating through things within Houdini. And you can do that with anything, right? I mean, wedging is another great example. Like there's a wedge workflow within ROPS, like that's where the idea came from. But when you look at the Tops implementation of it, it's like, it makes the ROP workflow like, what? This is insane how this worked, because like it never felt like you were getting the idea of what was happening before you had to start running it. So sometimes you would like run a wedge, and you would think, oh, it's going to do this thing. And then like you have to wait for the files to start being created before you can even like really process what it did. And like, if it errored, you're kind of like, oh shoot, I guess I did this wrong. I need to go back. With Tops, because you have those work items, you kind of know what's happening along the way. And if you're not familiar with what wedging is, a great example is something like, maybe a fluid sim, right? And you wanted to do it with varying levels of viscosity. You could set a wedge that will calculate or will preset between maybe a certain range, like say 1 and 1,000, and you want 5 wedges in between there. You could do them, in 5 even increments between 1 and 1,000, and it will change that parameter for each work item as you go through. And the other thing that's really amazing about tops, and isn't something that a lot of people think about, is that you can use it for any ROP operator. Even something like writing caches to disk, right? If your cache doesn't need to be time dependent, like if it's not a simulation, a ROP or a top node can actually execute that in parallel in with all of its work items. So it doesn't have to one frame at a time go through. You could chunk it into different groups. You could have it all just run kind of sequentially and just run through your whole your file cache. There's so many different things there. Like say you have like a kind of complicated process that needs to go through maybe a bunch of for loops in a network, and it takes 30 seconds to calculate this once through, but it's only using maybe 10% of your processor power. Well, in that case, you could actually split it up and do 10 of them at the same time, 10 frames at the same time, and have that calculation be done in a tenth of the time on your same computer. Now, if you're working on a laptop, let's say, and you only have like 8 cores or something like that, you're not going to see maybe the biggest improvement with times and things like that. But if you're on a modern workstation or desktop, you have 16, 24, 32 cores in your machine. That's a huge, huge benefit for you, because you can split those things up really well and do a lot of stuff there. And it really turns your personal computer more so almost like into its own little like mini render farm. And if you're interested in tops, which I wasn't even thinking about this, but probably before the end of the year, there will be a tutorial on the Side Effects website that'll be from our education intern. His name's Daniel Lee, and he did a whole thing about tops, like making a procedural city, how that works, how to wedge those options and things like that. And that's going to be coming out hopefully before the end of the year. I know he's done with it, and it'll be going to some of our internal stuff. I think it just has to be go through the marketing department and get some prettying up. But it's going to be really great. I've gotten to watch all of it, and it's a really, really good introduction to just how tops works and get you up to speed on that. So keep an eye out for that. I'll probably mention that again when it comes out. But I think that's one really underutilized or not appreciated part of Houdini, maybe from the freelance or MoGraph kind of like, individuals that are working and not in a big studio. I think big studios see the work of that, what the benefits are of that, because they're used to doing pipelines. And that's kind of the idea, is that it's your own personal pipeline that you can build without having to code anything, which is, you can code things in there, but you don't have to. So it's pretty neat. I don't know if any of you guys have ever played with tops, but honestly, for me, anytime I'm like about to do something that maybe needs like repetition or iteration on things, I'm always like, okay, how do I do that? What am I going to do in tops? And how am I going to make this work? So I don't know if that's something that any of you guys have played with in the past, but it's a really great kind of workspace to be able to get those things out. So that would be probably one of the biggest ones. I don't know if there's anything else that you guys are like, maybe not so that you don't think are underutilized or not appreciated, but just seems so maybe mysterious or weird. I don't know if there's any parts of Houdini that are like, what is this even? How does this work? Or like, why does this even exist? I'm sure there's some, but if you guys have anything like that, please drop a question, drop a message in the chat. So yeah, that's my 2 cents on some underutilized, maybe not appreciated aspects of Houdini, or just maybe misunderstood aspects. Insert Matrix meme, show me. Yeah, so I can show you real quick. We can do a quick top thing. I'm not going to go into it too deep because There's there are certainly some tricky parts to it that I don't want to go into for an hour or whatever. But um, let's see here. Let me see if I can find a good way to do this. Let's see here. All right, let's look here and see if I can see if I have any assets on disk here that we can play with. Yeah, here, resources. Oh, you know what? Do I have some Quixel models? I think I do. Okay. So I can definitely pull something in here. Let me see if there's any better models here that I have. Do I have any scans? Yeah, maybe that would be good. Oh, these are probably going to be that might be perfect to show what's going on here. All right. So let's just drop a geo node down real quick. So the cool thing with tops is you can kind of put them anywhere. There is like a task node context, but I rarely ever do it in there just because it doesn't really doesn't help me per se. But I usually put them next to things. So like we'll call this columns because I've got like a few columns here that we can mess with. So we'll say geo columns. I think I can spell. All right, and I'll just put a top node down here. Top network, I'm sorry. So this is a top network. We'll jump inside. Schedulers basically are just a way of the computer or your system controlling work items. When Daniel's thing comes out, he'll go into that really well. So just understand that it's kind of controlling everything. You can see here it's controlling the number of slots and some stuff like that. You can set basically its defaults to a quarter of your total CPU. The reason for that is usually a couple of things. Usually when you're doing multi-threading, the number of cores in your machine are usually actually the number of threads in your machine, and those threads each go into one core. And so you want to make sure that you're kind of using those two threads / one core as one unit. So dividing it by a quarter, make sure that you get that first of all. But then on top of that, you don't want to over allocate memory to each core of your computer. These are all weird kind of hardware issues, but like you don't want to have like one core that only has 1 gig of RAM that it can work with at a time. Because if you're splitting your RAM up into say 32 pieces, that's gonna you don't want to diminish the amount of RAM each CPU kind of has access to. So a quarter, there you go. Anyways, so that's what this does. So let's do a file pattern. So this basically is just going to find files in a specific place and make work items from them. So here's my pattern. I'm going to go over to here and let's go to my D drive. I have some resources here, models, scans, columns. Great. All right. So we're going to do this right here, right? So I'm going to hit accept, but instead of this, I don't want it to just be that one. I'm going to hit a star here. Or I was going to. What just happened there? All right. So star is going to be better, right? Because that's going to be searching for, that's basically just wildcard in Houdini, right? It's saying, give me anything that starts with this, and whatever the name after that is whatever, fine. Give me those. So I'm just going to hit generate node, and you're going to see that this is going to make 7 work items here, right? So now at this point we have 7 work items, and if I double click on it, it'll bring this up and say, okay, this first thing is looking at c1.stl. If I look at the last one, it should be c7.stl, right? Okay, so we've got those working there. And what I can do, since this is just looking for a file pattern, is I can say, cook this node. And so now it's cooked it. Since these are in this dark green state, that means that this has been processed and is ready to go, right? So now each of these is going to kind of call all of these different attributes that are inside of it. So when I click on that, it's kind of making these things live, right? So I have this file name, this extension. These are attributes that I can call up. And so what I can do is I can go up here. You can also see that these dots are now in this little top net as well. Anything that has this orange flag set to it will be seen up here as well. So I'm just going to do a file node here. Often you would do this part first and then do the top net after it, but I'm just kind of going back and forth here a little bit. But what we can do is we can just build up this real quick, right? So we can say, we'll just grab one of them again, and we'll say that this is what we want to bring in, right? And so if I, make it big, there it is. Great. There's our column, right? That we're loading in, and this is pretty big geometry. So there's obviously some stuff we'd probably want to do with this. Not in the least wanting to reverse the normals on it because they're inverted. That's why it's blue like that. So anyways, what we can do here is we can actually take one of these attributes. So if I click on this, we can see that there's a file name right here. So what I can actually do is instead of having C1 here, I can call any of these. So I'm going to do a backtick and say at file name, just like I would in Vex or anything like that. And this shouldn't change at all. It should be exactly the same. And it's going to evaluate exactly the same, because if I middle click on this, it's going to say c1.stl because I have this selected. So that means that this work item is live kind of in my view right now, or in my scene, and this file name is getting put into this part of the file path. So now if I click on this one, it's going to take a second, but it's going to load the other one there, right? So we have all of these live now. All of these columns are able to be iterated over, right, in our work items. So let's just say I wanted to do something like, let's do this. Let's do a poly. Well, first let me do reverse just to make sure that this is clean, right? So we'll do this. Okay, it's reversed. It's white now because its normals are the right direction. Oh, let's do a transform just to make this a little bit better. So it's not 250 meters, but we'll probably do 0.01, right? So now it's a more reasonable size for a column. In fact, it should probably be the other way. I'm guessing it's actually upside down. So we can do, we can do many things here. Obviously, we could do a match size. We can do this and just make sure it's minimum here. And what I can also do as well, actually, in fact, I can do a transform above this. So I only have to do that once, and I'll just translate this this way. Why is that not working? Nope, not translate. That's the wrong thing. I don't want to translate. I want to rotate. It's like, why is that not working? Just going to rotate it 180. And I'm doing this super messy just because this match size is going to pull it right up into that right position, right? Because it's set to minimum and it's centered on the other two. Match size is awesome. I absolutely love that node. It's so great. And you can also match size to objects. So if you put an object in here, great. All right, so let's do a poly reduce here. Drop this down. And this will be something we'll drive. It's going to be maybe a little bit. It's going to take a little bit of calculation here, but I guess that's not bad, right? We can use this to our advantage, right? Should be fine on my machine. And then we'll do a file cache at the end here because we're going to write these out to disk. And what I'm going to do is, sure, we'll say hip/geo/columns. Great. That should be good. Actually, you know what? I'm not going to do that one. I'm going to do a geo. Yeah, raw. Do this instead. So the reason I'm going to do this is because it's not going, like, the cache is great. The only thing is that sometimes when it's doing a lot of stuff under the hood. In fact, it has its own top network in there. So I kind of just am going to do a plain ROP geometry, which is just going to write out geometry. But this way I can kind of determine exactly what it's about to do. So I'll just do this columns like this. And then what I'll do here, I'll kind of go a little crazy here. So let's do another one. We'll do here, we'll do at file name. And this is basically going to just make sure that each of those file names is going to be in its own folder, right? So now we're using that same thing to make a folder here, right, in our output. And the other thing I'm going to do is change this poly reduce. So let's do this. We're going to have these files here, and let's do a wedge. So we'll do a wedge here, and we'll do just, maybe we'll do 3 wedges on it. I'm going to do 1 attribute here. So what I'm doing is I'm doing 3 variations now, and I'm going to variations on just 1 attribute. I'm going to call this attribute poly percent, I guess is what I'm going to do. And because what I'm going to do is change the percentage of this, right? Of how many there are. So let's do between 1, no, not 1. That's ridiculous. Let's do 20 and 100. Let's do 20 and 75. I'm just going to keep changing my mind. So let me do that. Okay. So we can do a range. We can do random samples. We can do all sorts of different things. I'm actually going to do, 3 will be great. So okay. So we've got this poly percent. We can do 2 different things here. We can choose a parameter that we're going to change. We can actually target a parameter in this, in any network in here. So I could technically, target this percentage to keep here, which would be called percentage. So in here, what I would do is in here, I would go to wedge. I'd say target parameter. I would look up something like object columns and then poly reduce. And I could pull up all of these things here. So let's see, make reduction amount, percentage. This is the one. So I could hit accept here, and this is going to overwrite that, right? So you could do this. This is one way that you could do that. That'll overwrite that target parameter, so you don't have to actually set anything in that that percentage field or whatever. But let's kind of do this. That's like the push method. There's also the pull method where we could come up here and we could say, let me just remember what I named that. Poly percent. That's right. Okay, so I can just come up here and just say at poly percent. And now this is going to pull that each time. Now for right now, this is not going to be happy. Probably should have thought about this because I'm going to hit escape because it's going to try to keep 0%. And that's just stupid. So let me go back in here because I don't have this cooked yet. So it doesn't have any of this information yet. So, what I'm going to do is I'm going to cook this node here. And now we have 21 work items because we took 7 and we're doing 3 on each of them. So the first one is going to be, let's just look at this. It's going to be this is going to be c1.stl. And we're going to do poly percent of 10 for this. The next one's going to be 42.5. And the last one will be 75. You can see there, those are changing. So as we change each of these, the poly percents are changing, the wedge, number and all this kind of stuff. These are just indexes and things like that it generates as well. So in this case, if I have this selected right here, it's going to be putting in the poly percent at 75. So if I come, this is now my output as well. So I can see this in this network here. So now if I come down to poly reduce, it's going to run the reduction and go to 75%. So now you can see here reduced to 75%. If I select this one, it's going to reduce it to 10%. So it's going to take us a few seconds more to calculate, but now it's reduced to 10%. Now that's interesting. That actually didn't update. That's okay. There it did. I think it was because I'm pulling that. Yeah. Anyways, I think it's just a comment thing that wasn't updating, but it is 10%. We can see that it definitely changed. And then the last thing is we're going to just do a ROP fetch here. And we're going to put this ROP path in as object. We're going to just grab that file. Nope, sorry, not that one. ROP geometry. That's what we want. So this ROP fetch, we're going to say generate node. And now this actually, I don't want to cook it yet because that'll start rendering it, right? But this is basically going to say, it's going to give us what the expected output is. Now we didn't put the name in there. You can see right here, expected output is Houdini Hangout, blah, 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 geo column C1, and then nothing.bgo.sc. So we have to name that. So let's do this. We'll do, we'll give this, we'll say another here, we'll say another at file name. So this is going to be C1, and then we're going to say underscore, and then we'll do backticks and say at poly percent. And now we're going to have C1 at 10, And so now each time we change this, I had middle clicked on that, so it'll evaluate. So when I click this, it'll do the 10% version, right? So now it's just calculating this, doing 10%, blah, 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 right? So now this should be C110. This one, when I click on it, give it a second, do its thing, and that should show up as C1 if I go down here, C142.5. So it's putting those percentages values into the name, basically. So we've got all that set. So now what I can do is I can come in here and I can just say cook this node, and it's cooking 16 of these at the same time. The other beautiful thing is Houdini's not locked up. I can do whatever I want. I can come back up here to this file node and look at it if I want to. It's running in the background. It's doing its own stuff in the background for me. So this is really the beauty of how Tops will help you when you're working. Because like here you can see, okay, yeah, it's running 16. It's waiting on these last 5. Now that's, again, because I have 32 core, 64 threads. So it's using 16. I could process that however I want to. But like, we can look at my processor here. It's definitely cranking along, but we can look at this and it's using lots of different cores and doing its thing here, blah, blah, blah. But it's now, finished some of these up, and we can actually go in here and look at these, right, if we wanted to. So I could then come down here, right, take the same output file and copy that. Oh, sorry, not the evaluated one, but this one here, hit copy, drop another file up here, and now if I click on this, it's going to load that in, right? At least it should. Let's see. Oh no, did it not? Did it show me as a liar again? You fool. Oh, maybe it's just too big. Nope. Try it again. Yes. Why is this not loading? Sorry. Oh, because I didn't change the name. Duh. I changed the name over there. Clicked on the wrong one. My bad. There we go. I was going to say, it should do something. All right, so there's that one, that one. Yep, they've all loaded in. So, I mean, this is kind of a contrived idea. I literally just came up with this on the fly, but you can see that I put out all of these different versions of this, and we can see that we have the different I guess you could say level of details of these. So this is really the beauty of working with something like Top. So hopefully that gives you a little idea there of what that's like, and why that's so powerful. So yeah, there you go. Show me. I guess that's it. That was a really contrived example, but hopefully it makes some sense and cool. Yeah. Good. And the real place that this is most helpful with is effects, I would say. So if you're doing a sim and let's say you wanted to, you had some idea of an area of like, I want this attribute. Yeah. Seating, right? Yeah. Seating for effects, or maybe I want this thing to be within a certain stiffness or have a certain, force that it's being affected with. You could wedge those things and think about this too, right? So, okay, this shows you kind of the path that these all take, right? So if I click on this, those are the 3 things that come from this. If I put another wedge in between there, it will multiply each of those things by however many wedges. Like, so if this is multiplying by 3, if I put another wedge in between here, it's going to multiply it by 3 again, per se, whatever, whatever the number is there. So, that is really helpful with that. And what you can actually do is you can run OpenGL renders through Tops, get an OpenGL rendering of your, yeah, exactly, the variant. It's adding more variations, and you can go, I mean, it can run away from you, so you have to be a little careful. But this course that Daniel put together hits all of the main kind of pitfalls. So I promise I will make sure that I promote that when that comes out, hopefully in a couple weeks. But really, the idea is that you can do all those variations. Then you can actually see you can render those all out as small individual thumbnails. And if you use the image magic right here, this node, this will actually make a montage for you in Houdini. So it'll actually take as many inputs as you're giving it, put them all down as individual like little panels, and you can run those over all the frames. So that's really helpful. There's also an FFmpeg in here as well. So that can actually render out the video from, yeah, no problem, man. Thanks for joining, Crossfader. So FFmpeg can then write out your video to disk as well. So these are all things that you can just process in a line. So like once you get that sort of set up, or at least have done it once, doing it in the future is super easy. So you could be like, oh, I've got this kind of dialed in. I want to see specifically where I want maybe this pressure wave on this explosion to kind of hit. All right, I'm going to run maybe 5 low res variations on this sim. I'm going to flip book them. I'm going to run them through OpenGL, basically an OpenGL render. And then in the morning, I'll take a look at those. You can just do those on your own computer. You don't need to have a render farm. And it's going to basically do that as best it can and run through all of that. When you do a simulation, you can, if it's a small enough simulation, say a Vellum simulation, you could actually have 3 or 4 or 5 of those going at the same time. So it's amazing. It's really, really cool. So can't kind of speak highly enough about Tops. A little bit, maybe not fully understood at all times, but really, really nice. So anyways, that is my my Tops little soapbox, I guess we could say. But yeah, so yeah, I don't know if you guys have any more questions beyond that, but or on that kind of note in general. Oh, that's fun. I don't actually use a green screen. I mean, I have a green screen behind me, but I don't actually use it. I let my computer just use it as like, it cuts it out for me, but I have a glass in my hand and it's completely invisible. That's just fun. Oh, that's funny. Anyways, so yeah, so I think that's one really it's so powerful, but yet it's also, again, a little bit different than just regular Houdini and putting down nodes. Like you use nodes, you use these things, but then there's these other little dots inside of there. Oh, I guess the other thing I should say is that the documentation is actually really pretty good on that. They break down really well. Let me see what the documentation says here. Hold on, let me pull this up. When to add things, when to remove them, and how to make things flow. I'm curious as what you mean by that, because I definitely understand what you're saying about artist-friendly tools, and that's, I have to say, and you'll hear this a lot, is that is something that Side Effects as a company is trying to push more towards. We don't want to lose what Houdini is, but we do want to have more and more artist-friendly tools that are in our tool sets, so that in certain instances, like when you're working with characters or when you're working with something, maybe it's cloth or you're doing something live in the viewport, that there's more feedback to the user versus it all being kind of techie and, code and things like that. So yeah, definitely understand what you're saying about artist friendly. I'm just curious what you mean about when to add things, when to remove them, how to make things flow. Like the order of operations, maybe. Yeah, that could certainly be what you're getting at there, Crossfire. I'd love to know if you can elaborate on that a little bit, because I'm curious about what you mean. Where a B scale doesn't affect other P scale. Oh, I see what you're saying. Yeah. Right. I think that's a good point. Yeah. One thing that can be really tricky with the attributes being on, orientations, things like that. Sure. I think a lot of those things do in some cases come with trial and error, which is hard. I think it's tough, but one I would say one time to know for like if you're doing a copy to points, right? And you're doing something and copying, which is super common in a lot of workflows, right? Especially in like MoGraph type stuff. Like copy to points is like that's the cloner, right, from C4D basically. It's similar. It's very similar conceptually as far as what it's doing. If you're ever working with a copy to points node, the first thing that you should be thinking about is what attributes are on the points that are coming in here, right? Because those are inevitably going to affect what you're doing, right? It's P scale, orient, color, even normals and things like that get copied over. So those are certainly things that you always want to be thinking. Anytime I put down a copy to points node, I'm always thinking about that. Okay, what do I have P scale on here? Do I have anything that's going to affect the orientation? There is a, let's see here. Let me see. Yeah, copy and instinct point attributes. So just as a little thing here, I'm just going to pull this up in the background here. Hopefully this will be easy enough to see. I'll scale it up a little bit, but let me just change over here so I'm on you can actually see what I'm looking at here. Yeah, for loops in their metadata. Yep. For sure. Okay. Yes. Like, so yeah, order of operations is kind of a good way of looking at that. So this page is really helpful if you're doing anything with like copying or working with data, because these are all the attributes that kind of do that stuff that you're talking about, right? This is a list of all of them. So if you look for copying and instancing point attributes, these are all the things that are going to get copied over, right? So like orient, P scale even is one, N, up, V, rotation, P, trans, pivot, transform. So there's all these different, it's kind of funny. There's trans and transform, or just translation. Sorry, not transform. But these are all really, important things to see, right? That, okay, these are things that are going to get copied over. This is another really great thing. Here's your priorities, right? So if pivot exists, use it as the local transformation of the copy instance. If the transform exists, do this. If the transform attribute does not exist. So this is literally a list of how it goes through and figures out what to use. So, and then this is the programming way of saying it, which I understand what they're saying, but it's just super funny because there's some people that look at this and they're like, oh, thank God, here we go. I can read this finally. But basically what it's saying is you can kind of work backwards, right? Like N and V are kind of the lowest level here, right? So if you have N, that is going to work. If not, use the V, the velocity. So velocity will actually reorient your objects when you're maneuvering them, right? So that's one thing that certainly can happen. And then from there, if you have N and up right here, using N and up, that'll actually orient your objects as well. So that starts to kind of be a building block for the orient attribute. So you can actually then there's some libraries that like QLib that'll actually let you take a normal and an up vector and use that to create an orient attribute, which basically an orient is a quaternion, but quaternions are kind of their own mystical fourth vector thing, which is a little weird. But anyways, so here it says, if the orient attribute exists, like that's pretty much second on the line. If transform doesn't exist, then look for orient. If orient doesn't exist, use N and up. If N doesn't exist, use V. So there's also here, like if the rotation attribute exists, apply it after the above. If P scale exists, things like that. So this is kind of your order of operations for those attributes and how they work in scaling and stuff like that. So this is a huge help as far as that goes. The other thing that you mentioned was where to place a mount, where to P scale, so the P scale. Yeah, so P scale can be a little tricky. A lot of times what I'll do is like, don't be afraid to delete an attribute, right? It doesn't have to be a scary thing to do an attribute delete, right? I very often will do that. In fact, it's usually encouraged after something like, say you do a vellum simulation, like, yeah, just like once those are good, and if you don't need them coming out of there, delete them, right? Because there's stuff that's going to come out of there that you may not inherently need, like velocity you probably want, or maybe orientation or something like that you might want. But all those other things in there, they could kind of dirty up your nodes down the line, kind of like what Crossfader was saying. So those are things that I'm always thinking about. Like, even just caching that data, you don't need those extra attributes on there. Every attribute you have makes your data bigger. It's maybe not something that's evident. Like, it's not just how many points you have and how many polys you have. It's how many attributes you have on those points and polys and detail attributes and, all these things. So literally you can reduce the size of your files by just cleaning up what you're saving out to disk in a cache or whatever. So I always, not always, but when I was working in production, very often I would just clean those things up, because it's like, if I'm handing some data off to another application and they're going to use my points for something in Cinema, let's just say, which was never simple, but I digress. You would want to make sure those files are kind of as small as possible. So bringing down the number of attributes that you're saving onto your different geometries and in your caches is a huge help. So I would say that's kind of one thing. So like if you're looking at those types of if you're trying to figure out those types of things, like what are these attributes doing, this can really help you, hopefully. And for example, here, like you can see, this is some blurring examples and things like that. So they're going to try to give you some good examples of what's happening here. And also they're showing, okay, we've got scale set, and what is it doing if you have P scale set, or, what happens if you have N up and rotation set. So this is a really, hopefully a really good resource, and is something, that maybe you wouldn't find just on your own, Googling or whatever. So copying and instancing point attributes, huge win there. So keep that in mind. But yeah, that's a great question. Yeah. I mean, I'm sure there's a lot more to what your question was, as far as like, like you said, when do you use a mountain, where to place a mountain and why, and things like that. Yeah, so mountain stop is tricky anyways, because it's kind of been deprecated, but they reproduced it in a noise, an attribute noise. So that's a little tricky, like of a problem to kind of figure out these days, but not difficult. You just have to know that the mountain always works along the normal direction. So if you have a normal attribute set, it'll noise along that normal attribute. So you can really kind of manipulate what a mountain stop even does by manipulating what your position or your normals are on your points. So something to keep in mind there as well. So I don't know if anybody else has any other questions around that specific topic, but I'd be happy to kind of talk about that before, diving into something completely different. So, but yeah, that's a really cool question, because it takes a little bit of a time to figure that out. But I think kind of the key there is, don't, like, if you need to make a P-scale, like your own P-scale data, and you have some coming in, you can delete it. Like if you're remaking the P-scale for some reason, do it. It's not something to really, like, I was doing some stuff where I was pushing apart points. Like I was using a relax to push points apart based on the scale of the points. And I was doing that actually when I was setting up these bookshelves and with stacking and different things like that. And I didn't actually want that P scale to get output, because once I output it, it's going to scale everything down. So I just deleted it before I output it. I used it to manipulate where the points positions were, but then I deleted it because I knew I wanted the P scale to be 1 and not be scaling things once I got into LOPS or wherever I was using it. So yeah, something to keep in mind there. So anyways, yeah, well, why don't we move ahead if nobody else has any other thoughts or questions there? Another question that I had, and like I was saying before, if you're just joining us now, you can put your questions in the chat. There are no questions that are too basic or simple to go over. If you have some really basic question you might be struggling with, and you know, even if it's just something like, how do I do X? And I can answer it for you. Happy to answer it. If it's a more high level concept, please ask it, drop it in chat. Be happy to try to talk through some of those things now. Yeah. So anyways, please feel free to put your thoughts or questions into the chat. This is an open forum for anyone to be able to talk and learn. It's certainly something where I learn things from doing this stream. So I am certainly not the end all be all in Houdini. I've been doing it for 7 years. There's people at Side Effects that have been doing it for almost as long as I've been alive. Maybe not using Houdini, but working in 3D and CG and stuff. So, I mean, I understand that there is a lot of knowledge out there that I probably will never have. So this is an open forum, and don't feel, you don't have to feel, like this is a safe place. This is a safe space. I won't tell your boss or anyone that you're asking questions about this, because I feel the same way, because I actually have to go and ask the developers how to do things a lot of times. And I feel like I'm an idiot for not knowing how to do this thing. But then I ask and they're like, oh yeah, it's a great question. Here's the answer, blah, blah, blah. And it's like, oh, okay. Like everybody wants to help everybody. So, and my boss isn't mad at me for not knowing how to do every single thing in every program. So anyway, probably because they don't know how to do every single thing in every program. So they're well aware. This was an interesting question, and I actually don't know if I have a great answer for it. What are your most used Vex setups to solve things far quicker versus what most beginners try to solve in 10 to 20 nodes to do the same thing? Don't know if I have a great answer for that. I would say one thing that I often do in a wrangle is, make some sort of reduction in maybe a point cloud. Like if there's a bunch of points that I have somewhere and I want to just like delete a certain random amount of them, you can do that with like a blast node and some other stuff, like if you're making attributes and things like that. But for me, I would probably just do it in a wrangle, because it's going to be quicker and not quicker in the sense of like building it, but I feel like I could probably build it quicker that way than like trying to think of maybe certain expressions that I might need to put in a blast node field or something like that, So a lot of times there's like simple things like that I like to do in wrangles. But another thing maybe to talk about just in that concept is like, oh, how do you do, what's faster and whatever in Vex versus in 10 nodes to do the same thing? Well, I think one of the things to think about when you're talking about using Vex or VOPs is that because it's such a low level kind of operation that's happening, those processes can usually scale much further than what 10 to 20 node chain could scale to, right? So if you put in 10,000 points into a VOP or a Vex node or, a wrangle or whatever, versus doing that into a chain of 20 SOPs, let's just say, they're probably all going to work exactly the same, right? There's going to be no real issue there doing that any of those ways. They should all be pretty performative and live in the viewport, right? But if you're doing something like, I don't know, you're doing like, so there's some crazy process of working with 10 million points and you need to do some process to all of those. Well, the likelihood of these 10 to 20 SOPs operating at the same speed as maybe one wrangle there's almost no chance that they're going to be the same. I mean, it's not going to maybe be, a minute versus 10 seconds or 1 second. But when you're talking about the scale of large scenes and large productions or large, projects or whatever, even if you're on your own and not maybe working in a studio or whatever, I would say that trying to do something in Vex, even if it takes maybe a little bit more pain, can often even if it's a little bit harder for you, might give you the flexibility down the line to be able to put something way more dense into it and have the same outcome, right? And have it be very performative versus maybe your node chain. And one example I can think of is we're tasked with making a hat. And I've talked about this before, and I think I've even shown it a little bit, but it's just something that always comes to mind because boy, it was really tricky to do. But doing some knitting, right? And having knit loops that then have basically yarn that's all thread. So you're making loops that then have multiple loops that go along them and get swept and all this stuff so that we could render it out, right? The other problem was the end result was C4D, and trying to put that geometry in C4D was a nightmare. It was horrible. It was not fun. Did not like the amount of data we were putting into it. But I did most of that in SOPs. I mean, there certainly were wrangles in there for sure. I don't have the network in front of me, but for sure there were things in it that if I would have done it like, I think I did that maybe 4 years ago now, gosh. And if I knew what I know today, then, I mean, I was doing for loops in SOPs, which is fine. It's a fine workflow, but I was doing it on such a large amount of data that sometimes it took like 5 minutes just to like process a hat, or 10 minutes to just load all these threads from this hat. So obviously if I could do that in a more efficient way, it would have allowed me to work faster, more, be more efficient in my job. So those are maybe the things that I think of more, rather than some default setup that I use. Just thinking about how far does this need to scale, maybe. If you're just doing a one-off thing and just screwing around, yeah, you don't need to do a wrangle for every step of your process. But if you're working in a studio, or you're even working as the Houdini guy in a studio, and you don't know what they're about to throw at you, having some of these really optimized VEX or VOPs in your network is going to save your butt sometimes, because it might be able to scale way easier to 10 million or 100 million points, whereas you do that in a bunch of SOPs in a for each loop, you're gonna want to blow your brains out at some point. But anyways, so that maybe is my best answer there. I don't know if anybody has any VEX setups that they think are really helpful or they are a go-to for them. Feel free to share them. I'd love to hear if you have some example, and maybe that'll jog my mind a little bit. So yeah, that's maybe my thought process on that. So if you guys have any questions about maybe VEX setups that are quicker or anything like that, you can drop them in chat. Again, please feel free to do that whenever. I am going to actually pull something up real quick here that I'm going to show you, because I want to talk about that actual project, because I think it's a really good use case for this next question. So sorry, I've used Vimeo a lot in the past, and I sometimes just really hate it. It's just kind of really annoying. Or at least I don't like how they've changed it. I feel like it used to be way better than YouTube, and now I'm like, I kind of wish I had nothing on here ever, because it's such a pain. All right, let me pull this up. I'm going to try to mute this real quick. Oh, yeah, that's right. Okay, so, all right, let's talk about this guy. All right, I'm going to pull this up here so we can see it. So this is sorry, I'll get that out of the way for you. You don't need to read the chat. I'm reading the chat. So this is the hat in question. So that we were approached by New Era to do this hat. And if you're wondering why does a small studio in Buffalo get to do stuff for New Era, which is a big company, it's because New Era is actually based in Buffalo. So they literally were walking distance to our studio. So we got connected with them and got to do some really fun projects for them. But this project was really tricky because a lot of times the creative would come to us, like we wouldn't come up with the creative per se. And so what this hat needed was two things. It needed to have this like crazy multicolor thread, which was one thing, which was really tricky to figure out how to do because each yarn has multiple threads twisted in them, and each of those threads were different colored in the actual hat. So that was the problem, first of all, from just figuring out what to do. Second, obviously their names are stitched in there, so I had to color those, and actually did that using what do you call it? Using an image map and then cleaning it up a little bit, but starting with an image map of text of the name. So that at least was accurate. Ooh, 531. There you go. V at P equals UV is way faster to type out in Vex than try and set up with stops. I know that's exactly what you're talking about, but it can whip this out in a few seconds. Then the amount of time it takes to throw it on a few nodes. The only thing about this because I was doing it today. Yep, exactly. See, there you go. Jog some memory. But yeah, for sure. And a really fun thing to do as well is if you have your UVs, using those to basically map your geometry into 3D space, which is actually what I did for this hat. So that would be way easier to do in Vex than in Wrangles or even Vops or whatever. Like that would be actually really easy to write in a Wrangle because you're basically just setting the point position to what the UV was. So it's kind of the opposite of that, which is a fun little process as well. I mean, there's more to it than that, but that's kind of basically the idea. But yeah, no, 531, that's a great, it's a great little tip there, which would basically just be turning your positional data into your UV space. So the only thing that would do, just as like, obviously that would put UVs outside of a 0 to 1 space. So if you're trying to keep it within that, it could possibly put it outside of that, but then you could use a node to just fit your UVs to, pack them into that space or whatever. But yeah, for sure. That's a great little example. So the next question that we had here was, how do you approach a problem? i.e., what are your most common workflows when you begin, a project? That was kind of the idea of this question here. So I'm going to try to talk through my thought process in a project like this that's really kind of complicated and is really kind of a convoluted thing to get to the end result, right? Because we've got these multiple threads that we got to figure out how to do. We got to figure out how to do these letters right in here in this and have that look decent. There's a lot of little elements here that really help to make the realism kind of come through on this. And this is rendered. This is literally not the final project. This is just the hat. So I literally just threw some lights in there and just rendered it. This isn't actually what the final project looked like. But like you can see here, there's even the way that these little loops come down into the text. The way that this edge changes is actually very accurate to the way that the hat is. This isn't like an error. This is actually kind of how this works with the hat itself. The one thing that isn't visualized here is there's a little bobble on the top of it as well. But so, we started this process and we were like, okay, I think we had to do a dozen hats, maybe 12. So we had to figure out how to do that, first of all. What are we going to do for the hats? What are we going to do to start? Blank slate. We have hats in our hands. I actually have this hat in real life. Oh, I should go get it. I should have grabbed it. I wasn't thinking of it. I literally have this hat because I grabbed it after the project because I didn't have a winter hat, first of all, which seems insane, but I hate wearing hats most of the time. But so anyways, I have this actual Seattle hat because it was my favorite colors of all the hats we had. So anyways, we thought of a few different things to start with, right? We were starting this process and we started thinking, okay, could we do this with some sort of texture? Could we do this with deformations? Could we do this with normal mapping? Like, what are we looking for here? Like, how do we do this? And so we started processing through that a little bit. We looked at some of the, because this is a knit hat, right? And there's kind of the two big worlds of like, putting things together, knitting and crocheting. Those are kind of the two worlds, right? And so my wife actually crochets little amigurumi things. If you're ever interested in looking up amigurumi, they're really cute little, it's like crocheted little objects. They're really cute. But anyways, so we're like, okay, this is a knit hat. So we kind of learned a little bit about what's going on here. What's actually happening? What are we seeing with these shapes and stuff like that? And we had to start to actually look at how close are we going to get to this object, right? How close are we going to get? And one of the main things with this hat is actually that each of the, and it's not shown in this because again, this was just showing the knitting for it, or the actual like hat makeup. Each team has an embroidered logo on the front of their hat. So their hat or their logo is done in embroidery on top of this hat, like right on the front of it. And so we wanted to get up close to this embroidered logo. So that was a whole thing. We were like, previously what we had been doing was using displacement maps to make their logos on all of the hats. Cause they were like, previous to that, they were doing a lot of these like liquid metal, shiny kind of like extruded logos. So we're able to make displacement maps for those and just displace those using textures. So that was kind of our first thought was, okay, we're going to find a texture that's going to be this knit pattern and we're going to use that and then get colors and do things like that. Well, once we realized how close we were going to need to get to show, a logo on your head in full scale, well, the rest of this hat is then super, super close. So all these little knit things are going to be really close there. And if you have just a texture that's used to make the deformations, you're really not going to be getting these voids that are actually created. There's actually a lot, it doesn't seem like it, but there's actually a lot of voids inside of there where there's little spaces, and that shadowing and spaces are actually what gives it a more realistic look than just having this flat texture. So how do we start from the beginning? That's always my biggest question is like, okay, what are the parameters for this project, right, that we're working on? How close are we going to get to it? What are some of the specs for those types of things? And I started to realize that we needed to get so close that the textures were just going to break down. We tried a few things with that, tried to render it. First of all, it wasn't looking right from like a shading standpoint. It was so hard to get that kind of like, that kind of fuzzy threaded look. This doesn't really well show that either because we did some stuff with shaders and this is literally just, I threw it in here and rendered it. But I think that alone shows how far this process goes with it because it has like a decent feel in this render. It's just not accurate to what the final was anyways. But, so we kind of quickly abandoned that and realized that wasn't going to be the process. So then from there, we started to realize that, well, this is going to be a little bit trickier than we thought, first of all, but we have to figure out how to construct this because it's going to be crazy. Now, we were working with Cinema and that wasn't going to be the answer because copying this many objects and things like that was just going to destroy its life. So obviously what we ended up figuring out was that we needed to actually, we needed to actually come in here and make these individual loops, right? These all had to be individual pieces of geometry. This is not what it does in the actual piece. We don't actually show it being created like this. But what we first had to do is figure out kind of the base structure for this, right? Like, how does this get knit? So like I was Googling knitting. We started trying to understand the different concepts of how you actually knit something. I watched more knitting mechanic videos, like literal machines that were knitting, than anything I've ever looked at ever. It was insane. We were going nuts because we were like trying to figure out how to do this. And we got to the point where we figured out, hold on a second. There's a couple things that look really complicated in here that really aren't. So like one thing is this, how this pattern changes here. You can see these have these ridges in it. And really all that's happening there is that's two different types of stitch, a knit stitch and a purl stitch. And all they are is one goes the other direction, right? So what we realized is that we could literally take these loops and flip them so they would go the other direction. And just by flipping them in certain patterns, it would do this. So we had literally one loop shape that you start with. And then if you flip that, you get these ridges. And so we just literally had to change that. And that was like one huge step in this whole process, was like, oh, that was it. We just literally needed to figure out, how does this knit work? And it did itself. Like I didn't have to figure out, oh, how do I shape this and do this here? I literally just had a grid of loops and flipped every other one, two, and then two, and then two, and then two, and then just back and forth. And that did this, made this whole process. So that was one big thing I had to figure out. Another thing that we realized was a huge benefit of this was that as we colored those loops, we could basically say, okay, this whole loop is going to be this one solid color. And because we were using Houdini, I could use that and use attributes and basically promote that to this entire loop section so that that whole loop section would get these dark colors versus the light colors, all of that. And then the last piece of it that it kind of really helped us with was this multicolor threading thing here, because the problem that we were running into was that there needed to be multiple colors kind of on top of each other, all rotating around as they looped through this whole thing. And really the real key to that was literally just starting with one loop here, right? So it's one loop that comes in, and then we basically put multiple, you can kind of see there, I'm not sure if there's a better frame for this, but we basically just had multiple knit threads going through each of those loops. And it was just that alone, having each of the, so I think there were like 8 per, like on the loop. So each thread turned into 8 twisting threads. We basically just swept those geometries along and it worked like that. So when I took those 8 and changed the percentages of, the in this case, it was navy blue, bright green, and white. When I changed those percentages of how many of those were getting those colors, it started to create this exact kind of mix that we wanted. And I could just change that per hat and be great. Now, if I had tops at the time, that would have been huge, because I could have literally done all of this processing with that. I literally had to I literally went through them, loaded a hat, did all the stuff, render, or save it to disk. Did all this hat, save it to so like you could see how this would be way better in tops. I don't think tops even existed when I was doing this, or we didn't have a version that had tops, whatever. But so that's kind of was the thought process that started going through that. And hopefully that gives you maybe a better insight into how some of these more complicated effects work, because it's not always about what's the perfect way of doing this. Sometimes it's actually kind of stepping back and looking at the actual real thing and saying, what's happening here? Because now, granted, this is insane. Like, you don't want to do this for every project. If I saw this hat at, only at this distance ever or further, I don't do this process. That's so stupid. But when you're in this close to it, right? Already this looks ridiculous because it only has one little thread per, right? And you can imagine, even if you just tried to make that thicker, it would look so stupid. It would look horrible. So like, this is the base loops, and then those get added on top of it. So there's so many, there's so much that you can glean from the real way of doing things that then you can, kind of go a little bit deeper from there with it, right? So, yeah, so hopefully that gives a little sense for how exactly that, let me just pull this over here so it's not in the way. So that's kind of how I approached this problem, and hopefully that's interesting. I see a couple of you saying, oh, that's cool. Like, hopefully that's interesting. And another question that was asked, and please, if you have any more questions about this or anything related to this, I'd be happy to answer it, because there's too much about this in my brain, and it's frustrating that I spend so much of my time in my life working on this. I mean, it wasn't that much, but it still is like, feels like it's consumed a lot of my life. So I'd be happy to answer any questions about it because it ended up being really fun to do, but it was also insane. So one of the questions that was asked of my, I don't even see where it was here now, but I know he asked it. So I'll just basically was, oh, my fluid wood example. That's right. So the question was about you want X object to feel like something else, maybe like, okay, so the example was I have these wood planks, but I want them to feel like they're kind of fluid in water. And we've actually gone through how this works. I've actually talked about this in a previous stream. So if you go back in the YouTube channel, you can definitely find that. But there it is. There's all the embroideries right there. So that's how close we actually get to these hats, just to see it. Hey, there's the actual finished piece. I forgot that was in there. So yeah, so you can see how close we get to them. We're like literally an inch away from them. The other really crazy thing I had to do was make this embroidery system here. So for this, I had to actually luckily we had all the logos, the teams they gave us all their logos and stuff, but I had to create a Houdini process to be able to, make those, basically have those, like bulge up like that in certain ways. And I had to kind of have different controls to be able to make that happen. But anyways, so he was asking a question about this project, which I did. Ooh, this is just my reel. Sorry. So these wooden wave right here, right? So we actually talked about this a while back. In fact, let me look and see if I can find where that stream is, because it was something. Oh, geez. Is that what I meant to do? I'm going to see if I can look it up on my YouTube real quick here. So if I go here, been this. Nope, nope, it's definitely not that. Oh, I'll find it. I'll find it and post it in chat. I'm not sure where it is. Flip driven GL. That's the one. 100%. That's the one. I'm just going to mute this, make sure it doesn't. So I talked about it here. So there it is right there. Sorry, I was just pulling it up. So we talk a little bit about how I did this and blah, blah, blah. There I am. It's so weird to see I'm not like a person. This is going to sound weird, but like, I don't like going up on stage and being in front of people. Like, it's not my favorite thing to do. So seeing myself is always super weird. So I know I'm doing a YouTube stream and all this stuff, but that's just the truth. I'm alone in my room right now, so it doesn't feel like I'm in public. So it's kind of strange. Anyways, so yeah, what was this? What were we looking at? Yes, this here. So this process. So the real way that this started was actually from some inspiration that I had seen. So what I'll do is I'll have a whole inspiration, place where I keep inspiration and things like that. So usually I get it from I'm of the time frame of when blogs were big. So I still follow blogs, which sounds like I'm a crazy person, but I do. And so I usually get a lot of inspiration from them. So for example, this was where I got the idea for this from. So Yes, the embroidery for the team's logo is a great example for when I ask myself whether or not the solution is shader or modeling. Yes, exactly. So let me just talk about that real quick because that is a great point. Let me pull that back up real quick because it could have been, and we did try it as shading, right? But let's just look at the Eagles logo here for a second. There's a couple things that were really, especially when we were at this distance from it, that were really, really hard. Um, okay. So embroider for the team. Let's talk about the embroider first, but I'll get to your question, Liam, in a second. That's interesting. Um, so with this, because we were so close, I think that was what drove us to say this really needs to actually be threads because there was a few things that were really incredibly difficult to get with the way that we were trying to do the shading, or at least the tools that we had to do shading or texturing and stuff like that. Maybe if we had something like Substance that could have been maybe more helpful for it. In fact, maybe that is a much better solution in the current kind of climate of um, programs and things like that. I don't even remember talking about Substance at that point. Probably because we just hadn't used it really yet for whatever reason. But um, the reason we ended up going with this was because there were some things like here you can see in the beak, for example, like that almost has like this metallic-y kind of feel to it. So being able to have these individual threads that were picking up highlights differently was the real selling point for going with this process because there were parts like that was one thing. The other thing was these literally stuck out so far in some instances that they would have felt way more flat too if they were just extruded geometry, right? And the other problem is once you're extruding out with like a displacement map, you're going to, if you try to push that too far, you can't smooth that very well, right? Because each pixel of the map has its own depth information. So that was kind of why we ended up with that solution, really, in this up close case. If we were further away, 100% I would have gone with textures. This was so much work to do. I literally was going through and drawing in curves that basically I'd put two curves in to input where these two, like, so I'd go here and here, and then it would create all of the threads in between, and then I'd give them some depth to how high they would go and then go to the next. So luckily I made like a little HDA that did that. But in fact, I don't even know if I knew it was an HDA at the time, but I think that's what I made. I did something like that. Again, if I would have done this today, it would have been a lot better, but you work with what you can. Anyways, okay, so Liam, your question is, for the hat, did you go from the straight to the looped threads by lerping? I've seen a few different ways people have executed this. Also, how did you keep the colors aligned so well? That's interesting. Oh, the loop. I think I know what you're talking about. You're talking about here, just when I'm transferring them. I'm think what is what you're saying. Like when these sweep up here, how am I doing that? Yeah, I actually think what I did was I might have. Oh gosh, I don't remember. Honestly, I don't remember. I really wish I remembered how I did that better. Um, I think what I did is I actually created. I think I had a. I think I had a point here that I was. Yeah, I probably was doing some sort of lerp type of a thing. All I can think of is LARP, live action role playing. That's all I'm thinking of right now. For some reason, it's just making me laugh. But I think it was something like lerping here. I definitely created a path that this would go in, so it wouldn't just go straight to it. I think what I did was I might have given a point here that it was going to go to, but then for each, um, oh, the other thing too that it doesn't, maybe isn't immediately obvious here, but each of these threads goes the entire length of the hat. And in fact, this is the way that this is done. We cut it out using like a pattern for how the hat would actually kind of work. We did this using the UV space, going 0 to 1 and UV space, taking the UVs from the hat and then cutting them out from this threaded geometry. So I basically made these loops that would go across and just cut it out and then popped it up into the position of the hat. So that's an Intagma tutorial. Go check that out. I think I might have talked about it here on the stream at one point, but that's where I got it from. So, I mean, I tweaked it. Obviously, this isn't just what they did. But yeah, so 100%, that is where you should go to look for that. I think what I did there in the middle, sorry, I'm pointing my screen as if you can see what I'm pointing at. What I did in the middle here was, I think I had another point that these were transitioning through. So they were like, this was the start point, this was the midpoint, and obviously the hat position here was the end point. And what I had here was, I think I had a point that would, I would have like a position that would noise based on what primitive number it was, right? Because each of these threads has its own primitive number. None of them, these are all separate threads, and they go the entire length of the hat. So as they're getting pulled up there, that's literally just one thread that's going across the whole thing, and then it builds on the rest of the loops from there. But that's how that is smooth like that. Again, this isn't actually in the spot. This was just something I did for fun. We never did this in the spot, but I just did this after the fact to just show like we actually had to build this crazy thing. But then how did I keep the colors aligned so well? I'm not sure what you mean by colors aligned so well. If you mean that based on like horizontal rows, I'm guessing that's what you mean. And like how they are in the words, Liam, I'm guessing that's what you're kind of getting at here. I'll give you a second to respond. But if that is the question, the reason that those can stay so consistent and so straight across the hat is because these loops are straight, right? These patterns are all going straight across the whole hat, right? They're all going 100% straight across like the UV coordinates of the hat. So once we had the UV coordinates tidied up, that fixed a lot of stuff, right? That helped. As long as we had clean UVs and they were fairly horizontal. As the threads converge, the words text line up precisely. Right. So because I was doing that, I think in this I was doing all of the coloring and all that stuff down in this flat version. I wasn't trying to do it like on the hat itself. Like that helped a lot. And what I'm doing there as well is I have each loop, before they're getting joined together, I'm coloring each individual loop. That's how when you get to this state here, you can see that there are literally 2 specific loops here that are dark, and then it goes back to light. And so because of that, it's keeping those colors really consistent as they go through that. I'm not trying to do that once I have all the threads. I'm doing that ahead of time and pulling that through the process, right? I'm not trying to kind of project that onto the, hopefully this is kind of maybe what you might be running into. I'm not trying to do it like after I've created all the threads. I'm doing it kind of before I'm creating the threads, or at the very beginning of creating them. So it's again, there's probably a lot of stupid things I did in this process, but yeah, I think that's what I'm, and you're saying as the threads converge, they line up precisely. I'm not sure if you mean here, the way they're converging here. The real way. Oh, hey Zach, how you doing? Glad to have you here. And thank you to everybody for joining in and chatting. It's super great. I love right there. Okay. Yeah. Here's what you're talking about. Okay. So the reason that those are lining up really well is because I'm using the UVs of the hat, right? So sorry, to step back one more level. The hat was first created as a actual just geometry model. We UV'd that and then took this grid. We then unwrapped that, right, and flattened it out, and then put that into UV space of 1 to 0, positional space that matched the UV space. So from 0 to 1, in X and Y, or in X and Z, flat. Now you could do it X and Y as well. I mean, we just did it flat on the ground. I don't know why. But anyways, then cut that out. And because those UVs, we'd already made them, I lined those lines up into that space, flattened those loops completely flat, and mapped those exactly to those UV coordinates. Now I kept the displacement amount in that flattening so that as you put the loops back into that position on the screen here, like into this hat position, so there's flat kind of pattern position, I guess you could say, like the way that you would cut out the fabric almost, or, if it was a piece of fabric, now that's not how you would do this, but if it was like a shirt or something like that, you would make a pattern for it, cut it out, and then stitch it together. Well, it's kind of what we're doing here, except that's not how knitting works, obviously, but conceptually it's sort of similar. And so we're taking the pattern, we're cutting it out, we're kind of stamping it out of this threaded loops, and then finding those UV coordinates and putting them onto the hat. Or into the position of the hat. So you can almost imagine that there's this floating kind of polygonal hat in position where this actual 3D hat is. So, and for example, this bottom part here, we actually had to make like a loop of geometry that went all the way around, kind of like that, whatever. So that the like knitting would go around as it like kind of is like flipped up, right? So that's how that was done. And the reason that it lines up really well is because we made sure that the UVs were pretty straight. Like we made sure they were nice and horizontal and all that kind of stuff. And that kept all of these things really, really straight. And I'm taking the color information and promoting them like through, like from the points up into the primitives and then probably back down to the points so that it's averaging it across the entire loop and not just each point position is getting a color. The whole loop is getting one individual color. So that's kind of how I kept it really clean and really tight. And also how the threads, when they're coming up into this position, it's just going into the position where they were in the hat. So that's how it's staying tight, because the hat was already pretty well formed and the UVs were pretty strong. So hopefully that sort of answers your question. If you have more questions about it, you could always, or if you like think of a better way to word it, you can always ask it in the Discord or whatever. But yeah, I think hopefully that answers some of the question there. But yeah, it's a great question. And it was a really complicated process to get through. And the text actually had to go through and paint to clean up to make sure that it was accurate, because we didn't really have a perfect font that fit those letters. So I had to kind of clean it up sometimes. Sometimes it wouldn't exactly map properly. The lines were really easy to do. In fact, I might have just painted those lines, honestly, now that I'm thinking of it. I might have just colored which ones I wanted green and white. I don't totally remember that. I think what I did was actually set groups that were going to be mapped to certain colors, and then I could just had a little color picker that I would choose, whatever team color I needed to go in those positions. So there's a few things that I've done that I've slightly forgotten. I actually should pull out, that would be a fun. Yes, exactly. And that's, like I said, that's what of course, yeah, no problem. That's what I got from the Entanglement tutorial. If you want to see the exact nitty gritty on how to do that, check their stuff out. I mean, it's probably a 4-year-old tutorial at this point, so you're gonna have to go back a little bit, but it's a great tutorial, really, really good. And I kind of worked from there, but it'll get you most of the way there. And now we actually have the Poly Scalpel tool, which is a labs tool that you can cut curves with other curves. And I wish we had that so badly back here, because it was such an absolute royal pain to cut the loops, the curves with geometry and make sure that stayed good, because it didn't work great. I mean, you made it work eventually, but there were some big caveats that happened there. It was not super simple. So if you are cutting curves and want to cut them with other curves, use poly scalpel. Amazing. Works really well. I actually think I had to make, if I'm remembering correctly, I actually had to make an extrusion on the curve to be able to cut it, and then like delete one edge or some bananas in a situation like that. I mean, that was a nightmare, but it worked. It ended up working, and I saved it to disk and never worried about having to cut out this pattern again. Anyways, yeah, where were we here? Oh shoot, sorry. I'm like trying to find this thing and going way too far. Anyways, so this scene here. So, thinking, this was one of the questions, was how do you think about something like this and start to process it? Well, the first thing is getting the idea, right? I didn't just come up with the idea out of thin air. Here it is, literally. Like, I did not come up with that idea. This is some art installation that looks freaking amazing, and I would love to see it in real life. I don't even know where it was, but probably somewhere in Europe or somewhere that I'm not going to be able to get very easily. Maine. Well, that's not too far from where I live. But anyways, just really interesting, like super unique looking thing. Like, just crazy. Like, I don't know how this person comes up with that, but I am not the person that's going to come up with these ideas. But I saw this and I was like, oh, a wave. That's cool. Like, how could you do something like this? And so this process here, you start thinking, all right, well, a wave, it's fluid. Could I do a fluid simulation? Well, that seems like that might be a lot of work. And then maybe a lot of times what I try to do is come up with the simplest solution, right? Because oftentimes, like kind of like an Occam's razor thing, like you don't want to go to the most complicated solution for something if a simpler solution is better, right? Or going to get you there more easily. So, I thought about, probably thought about things like, could I sculpt it? Could I, do whatever? Could I do some sort of geometry and make these things scatter and do a surface and something like that? But like the flow really is a big part of it, right? So like when you look at this, the real thing that I'm seeing here is that like there is this flow that's kind of happening here, right? And like these are actually moving in a direction that feels like a wave, and that's really what's driving it, right? If you didn't have that positional kind of aspect to it, it might not feel exactly the same. Now, certainly there's ways to do this otherwise, right? Like there definitely are other ways to do it. That's always the case in Houdini. There's always a million ways to do everything. But, even just sitting here, I'm thinking about a couple other ways that maybe you could do it. Like, could you start with a surface and create some vectors on it and kind of push them in certain directions, have them moving in a certain direction, and then, take those vector, attributes, and then maybe make a volume of area that you want points to be scattered inside of, and then have those points pull those vectors and start to work in that field position, right? The position that they are, and then start to, sweep some geometry across them. Sure. Something like that could certainly work. It'll give you some depth to it, give you some movement and things. But what I really wanted to do was the animation part of it, was like actually make it move. And so that seemingly would be a little harder to do with maybe a more math oriented, I guess. Not that the fluid solver isn't math, but so anyway, so what I started to get to the point of was like, okay, I know how to do this in Flip. Like I could make a flip sim that's going to just push in a direction and make a big wave on a wall. Like that is not overly complicated to do. Like that's a pretty straightforward process. But then from there, you kind of start thinking, you have to start thinking about a few things. Like you have to start, if you're going to go down a path like that, you have to start kind of going into your mind and start thinking, okay, well, we've got points, right? But I don't want all the points because that's insane. Like I don't need, let's just say I was doing it with 1,000,000 points, right? That's fairly solid, but not like crazy fluid sim. Okay, I do it with 1,000,000 points. Well, I don't want 1,000,000 pieces of geometry that are going to get sourced into here. I'm probably going to do some sort of a trail through here, right? Like have a trail sop, make trails for me and have each particle kind of be followed and move through the scene. Like that is a solid workflow, and I know how to work with that. And you can kind of change the length of it by how many previous frames it's going to cache and make a line out of, blah, blah, blah. But then another thing you think about when you're thinking of that is that Flip has a couple built-in things that it does, like reseeding. So that actually means that it's going to reseed your points from time to time, which means your point count is going to change. So you need a way to make sure that your points that you're keeping, that you're going to have go through this whole process, are going to kind of continue and aren't going to just get deleted or add new ones in. So, because if they do, then everything freaks out and you need ID attributes, and even that, could be a little tricky. So, knowing that, like turning off reseeding is a big part of it. Now, it's not going to be the most physically accurate simulation, but you're trying to do an art piece anyway, so it doesn't really matter. You're not literally trying to, keep your fluid perfect. So knowing some of those things about how the solvers work, or what even just the output of them are going to be, is a huge part of knowing how to kind of go through these processes. And from there, I kind of just went with it from there. Like, then I was like, okay, well, if I keep it reseeded, I know I can just remove certain points from the sim. There shouldn't be a changing point number, so I shouldn't have to even really worry about an ID attribute. I can add one, but don't really have to. And it should stay stable. It shouldn't be jittering or anything like that. And I can just follow these points through the simulation and just pick a random percentage of them and delete the rest. So maybe if I have 1,000,000, I'm going to stick to 1,000 or something like that, or 10,000. I don't remember exactly the percentage I used. It's probably like 10,000. I don't know. Oops. But so from there, it's kind of just starts to make its way through. Now, one thing that I did in this case here was I actually added some geometry to the ground, because I didn't want it to just be a flat and then into a wave. I wanted it to have something going on there. So I added a couple little humps into the ground, even though if you look at the scene beforehand, it's flat. I made sure that there was a few little lumps in there to kind of kick it up and make it do some interesting stuff before it goes over. There's also a curve there too, because I really wanted to make sure that was accentuated. So instead of just having it be totally flat against the wall, I wanted to make sure that it had the chance to kind of curve up and over. So there's a bunch of invisible geometry that's colliders and things like that in this scene. But so I mean, really, that's a big part of it, is like adding imperfections that will like create interest in your scene, right? Like that's a big part of it. Like a river isn't flat on the bottom. It always has bumps on it. So like that was okay, I'll put some bumps in here so that it'll have some like little rapidy kind of things to go along. I mean, it's very smooth. I didn't want it to be like rough and crazy, but that was kind of the way I went about it. And then from there, just making sure that the orientation stayed pretty stable was using some of the parallel transport processes that, again, that was an Intagma video that I had seen, but there's also, you can get that through mops, even just through with the just free version of mops. They have a parallel transport in there that you can run, and that'll make sure you get these really clean transitions through curves. Like as they like maybe flip over on themselves, it'll make sure that the geometry doesn't do some crazy thing and like flip back on itself. So when I swept the geometry here, that was exactly what I did, was I used something like that. Or there's also the orient along curve, I want to say, uses a similar process and is pretty stable as well, and that's just in Houdini itself. I don't think I used that in this case. I think I used parallel transport, but who knows? It's hard to remember every single step. But yeah. So, that's kind of like, if the question, just to kind of go back to it, was how do you approach a problem, right? And I think usually the best way to start is like, what's the simplest way to do this? And experiment with that a little bit first. And then if that doesn't seem to get you where you need to be, maybe try the next most complicated thing that you can think of. Because a lot of times Houdini does make it really easy to just go, what's the hardest way to do this? Because it can do it. You know what I mean? Like if I want a crowd of people and they're all getting blown up and their body parts are flying around or whatever, okay, I'm going to fully sim every single bit of that and do this and do that. And like all of these different things, like I want to have these things ripping apart and there's, maybe this stuff's coming out of it or whatever. Like oftentimes we think we're going to do this in one monolithic simulation. And there was a comment made on the Discord. I think it was like a couple days ago or whatever. And it was like, well, sometimes it's better to not try to do something in one monolithic simulation and instead simulate this, then simulate this, then simulate this, then simulate this. That's how a lot of movies work, right? They don't try to have the destruction sim and the fluid sim and this sim and that sim all working together. They oftentimes break those up. Now, sometimes they will do things together, right? But more often than not, trying to be smarter about something is going to get you a lot further, because many times we like to, I think that like we're the, try to prove that we're the smartest in the room and we know how to do all of these simulations in one thing and it's all done together and it's all physically right. But at the end of the day, if the most physically accurate version of something looks 99% of this fast cheat that got you through this process 10 times quicker, well, you really screwed up by going the hard way, right? Like you could go that way, but you shouldn't probably. So, that's kind of, I think, the idea here. And that's something I've had to learn over the years. I always wanted to do something the most absolute, physically accurate, perfect way just to be cool about it. But now it's like, what shortcut can I take that's going to get me most of the way there? Like if I have something that's floating in this fluid, well, yeah, you can do feedback forces and make sure it's floating and blah, blah, blah. But like, what if there's a way to just figure out where that surface is and just link it onto it? Like that's easier. You know what I mean? Like, so those are the ideas that I think a lot of times you have to throw out as an effects artist, right? Like you don't need to do these things all the perfect way. Like there is a way to do it that is fast and maybe a little easier and, can get you most of the way there. So hopefully you're not hearing me say, find shortcuts to do things. Like, I don't think that's the best way of doing things. Like find every shortcut you can and cut every corner you possibly can. But being smart about things is really a huge thing that I think you have to learn as like working in effects, and especially in a software where an art director could come to you and say, I want this smoke to do this thing and gravity turns off halfway through and then all of a sudden we warp through a wormhole and space is bending and a rocket explodes and all this stuff. Like all of those things are doable in Houdini. It's just a question of like knowing your time limitations, knowing where, what things you can actually accomplish in those limitations, and knowing the smartest way to do it or coming up with better solutions. So I worked for 7 years as the only Houdini artist in a studio, and was kind of on an island, which was fine in a lot of cases, but sometimes was really tough. And so that's a huge skill that I had to learn the hard way many times, where, you get yourself in a corner and you're like, shoot, this software can do everything, but that means I have to know how to do that too. So it's like, it's kind of that chicken and the egg, which comes first. So sometimes finding those little smart ways of working is the best. So, and it's always, the trouble is always finding those, right? But, sometimes looking for that instead of how do I blow up a Star Destroyer in Star Wars, starting to understand some of the simpler things and kind of working your way up to those things is the best way of maybe learning in some cases. So, cool. Let me just see here. I think I had maybe one more question on this. Oh, I don't have a question, but I have this. So the question was, well, I don't have an answer, but the question was, how does man versus machine / panoply / XK set up their stuff? How do they do what they do? How do they make their stuff look so stinking cool and make it amazing and whatever, blah, blah, blah. And, so if you don't know, like Panoply, like they do really awesome stuff, right? There's Intermission. This is really like, these things are crazy. Like these guys are super, super talented. Simon Holmendahl, I think, is the one that did all this. Yes, I think so. And so just so cool. Like just shut up. Like you guys are out of control. Just ridiculous. So, I mean, like these are the things you see and you're like, oh my gosh, how do I ever get to that state, right? Like how could I ever get there? And it's fair. It's a fair thing. I feel the exact same way. I look at these and I'm like, gosh darn it. These guys are geniuses and woe is me. I will never be good at anything. But I think the thing to remember, first of all, is that usually these aren't, especially in these cases, right? Like when you see these projects and when you see Man versus Machine and they're doing the shoes that are knitting and crazy stuff, it's not one person doing it, right? It's not one person doing every single one of those things. So in most cases, I can't say that, I guess, for 100% certainty, but that would be my guess, is that there's multiple people working on it, first of all. Oh, shoot, sorry. I didn't have my screen on. Here, we're looking at Panoply, right? Their stuff is great. I'm looking at it and I'm talking about it. You can't see it. Sorry. My bad. So anyways, yeah, so here's some of their pieces. Intermission and Vor and Bump. Do is just insane. Like, that's ridiculous. Like, come on. Like, what the heck? How do you even... Yeah. So I see a lot of these things and I'm like, holy crap. Like, I can't just do this off the top of my head. Like, sure, I could probably emulate these now that I've seen them. I don't know how they come up with them out of their thin air. I mean, that's genius. But my guess would be that they've seen other things, that have inspired them. And they're using inspiration, right? I think that having inspiration boards for things is super great. Like, huge recommendation of doing that. I did that when I was in like doing design work mostly. I would always find inspiration and grab them together so I could just fill my mind with interesting looking things all the time and have a place to come back and look at them quickly. I mean, this is a great inspiration board. You could just come back here, but, inspiration boards, you emulate their work anytime. Yeah. I mean, there's a part of me that I would like to do some of this stuff, but also at the same time, like, I have I really like, if I get to know some of these guys a little bit better, I will probably talk to them a little bit more about this, but like, I feel a little weird looking at someone's stuff and just trying to reverse engineer it and tell everybody how to do it. Like, I know that that's not exactly what I'd be doing because I wouldn't be able to do that perfectly, but I feel a little strange about that, to be completely honest. And I struggle with that a little bit because I see things that I'm like, oh, this is really cool. I oftentimes try to find things that aren't done in Houdini, or I know aren't done in Houdini, or I'm assuming aren't, or are interesting, and just do that. Now, there's some things that I'm like, okay, we'll talk about how to do this thing, but like, I struggle with that sometimes, and I don't know. I don't know these guys really at all, so like, I don't know how they would feel about that. But yeah, that might be a major fail if I try to emulate their work. So we'll see. But I'll do you one better, because I did just find this the other day. So if you want to actually know how some of these were done, all you have to do is... Oh, that's not the right tab. Where'd I go? Where did I go with it? Oh, I have it pasted here. So I'm going to paste it here. Let's see, there it is, I think. Oh, no. It's got an extra thing in it here. There we go. So I'll drop this link in chat so you have this. But Simon actually recently did a talk on this. And now he doesn't go through the whole thing, right? But he did a talk about all of these pieces, right? And he gets in the node network and it gets crazy. So if you're, for those of you out there that are wondering how do how do the minds of these people work? I mean, they put notes down just like the rest of us, you know? There's a lot of them. Some of them might have crazy wrangles in them, but um, he actually said an interesting thing here. Actually, he said that he doesn't like to do. He likes doing for loops and vops, which I was like, huh, that's interesting. I don't know a lot of people that do that, but hey, you can. There it is, right there. That's how you do it. So, yeah. So this is Simon Homendahl's thing. So if you haven't seen this yet, watch it. 100% watch this, because this, I can't explain what they're doing. He can, and it's really interesting, and he goes through it really well. So yeah, check that out. But I think the thing to know is that they put their nodes on one bank. Exactly. Just like the rest of us. They have to use all the same nodes, right? They're not using any special nodes. Although you can make your own HDAs, right? So they have some of their own nodes. So yeah, I mean, there's always something more to learn, right? There's always, seems like they're just scratching around and see what happens. Yeah, exactly. I think that's 100% correct. Like, they've been doing this for, like you said, 10 years, maybe 15 years. They just have they've done the things wrong enough times that they've kind of, figured out the things that are working for them, aren't working for them. And in some cases, like, they find their style, right? And they kind of stick with it. That's what a lot of designers will do too. And I think it's fine to like find your style and hang there, right? Like, if you're somebody that wants to do realistic effects, do realistic effects, do explosions, do water, do that stuff. You know what I mean? Like, you don't have to know how to do every single thing in 3D, right? Like, you don't have to know everything. And if any, my maybe closing parting knowledge is that was what I've learned through doing this stream over the past now almost a year, is that it's okay to not know everything, which is a horrible, terrifying feeling as a creative person and as a technical person. Like, just the worst. It feels so bad to like realize, crap, I don't know this. But it's something that I've had to acknowledge many times in the course of doing something like this stream. And it's something I've learned recently. And like, that is something that is really okay to learn, and is hard, but is good to learn. So I'm certainly not a grizzled old veteran in the field or anything like that, but that's something I would want to make sure everybody knows. And another thing is put yourself out there, right? Like that wave thing I did for the Mardini competition for Side of 2021. And because I did that, I made some connections with some people at Side Effects because that one actually won the day or whatever for that, or came in second or something. I don't know what position it was, but I was super pumped and talked to a couple of the guys at Side Effects, and they were really nice, and ended up then talking to them when I started doing this stream. They were really nice about stuff, and also were really, really friendly and great. And I ended up applying for a job, and because I did Mardini, and then that made me want to do this stream, and then I saw a job posting, I was like, go for it, I guess. Like, that is my path to where I am today. And like, putting myself out there feels horrible and is super scary. Doing this stream every single time has like a level of fear to it that I have to deal with. Like, I don't love being in public, just being honest. Like, that's not my thing, but I love talking about Houdini. So, okay, I guess I'm just going to do it anyways, because I enjoy this. I love chatting like with you guys and like having these conversations. And like, if there's 2 people in here and we're all just chatting about Houdini, like, great. That's 2 more people than I get to talk to on a daily, than I used to get to talk to on a daily basis. Now I get to talk to a lot of really cool people about Houdini every day for my job, but I still like to do this because this is other stuff that I get to talk about. So anyways, so that's my little nugget of advice. Take it for what it's worth. But hopefully this was helpful Q&A kind of scenario. I don't think it'll be anything that I do like every month or anything like that, but definitely is really fun. I like the questions, but also like if you guys are having these kind of questions and see projects and see things like that, please get on the Discord and drop ideas in there. I know some of you guys have already, and that's super great. I'm so grateful for that, because for me, it's like, I know what I want to do and what I want to play around with, but that's not always what everybody else wants to play with. Like if you look at the first streams I was doing on here, it was just stuff that I wanted to do. And what I wanted to do was I was making F1 visualizations using like map box stuff and all this kind of crazy things. And like that's what is fun to me, is like, I want to visualize F1 qualifying on like tracks and like do all this crazy stuff. Like that's just my random weirdness, like of wanting to play with Python and play with Houdini and integrate these things and all this stuff. But like that, that isn't what everybody wants to see. Now, maybe you do want to see that. You can go back and watch those old videos and see what the heck I was doing and screwing around with. But I would love to know what everybody wants to hear about. So please, 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 like, don't feel like weird about posting in there, feel like you're taking advantage of me or something. Like, I'm asking you to do this, please, because I really, really enjoy this. Like, this is 100% fun for me. I literally get paid $0 for this. I don't care. Like, it's just fun. Like, so I would love to hear more and more about, what anybody's interested in learning, and truly for me to learn too, because I'm going to poke around with stuff and learn new things and all that kind of stuff. So, yeah. So hopefully that is, that's where we'll leave it for the evening. And, hopefully it was a good little thing to kind of break down some projects, hear about some maybe things that you wouldn't have known about otherwise. I will certainly make sure to put that TOPS, course. I'll make sure to promote that, coming up, when that gets posted. I promise it's really, really good, and it'll be well worth your time. I don't think it's super long. I want to say it'd probably be like an hour course, but, yeah. And please feel free to connect with us on, Discord, Twitter, whatever, if you want to reach out to me, whatever. But, please keep putting suggestions in. And I've already seen some of the new suggestions that have come through recently, and I've already been pondering over them and thinking about maybe how we'll do it. So, anyways, so that is that for today. Thank you guys so much for coming on and hanging out. And, this is kind of exactly what I always wanted this to be like. And hopefully we'll have some more, guests in the future. And, so I think next year could be pretty interesting. So, as we're getting towards the end of this year, keep an eye out, and we might have some guests coming and some interesting things to talk about. So bye everybody. Thank you for joining, and I will see you next time.